Welcome back. In this lecture, we're going to talk about image thresholding. In some computer vision applications, it is often necessary to convert color images to grayscale, since only edges and shapes end up being important for certain applications. You don't actually need to know the color of someone's shirt, for instance, to get the outline of a shirt. Similarly, some applications really only require a binary image showing general shapes, not even just grayscale, just black or white. Thresholding is fundamentally a very simple method of segmenting an image into different parts. Thresholding will convert an image to consist of only two values, white or black. Later on, we'll see some other examples of thresholding that actually convert to some sort of grayscale and do have values in between black and white, but typically we're just going to be going with a straight binary threshold that turns values into black or white. So what does this actually look like? Basically, here on the left we have a color image. So here we have some snow, a bridge, a tree, and then a building in the background. We take that color image, convert it to grayscale, and then we apply an image threshold, which converts that grayscale image into a binary image where values are either black or white. And we obtain still a lot of information. So now we can see that we still have the general shapes. I can tell there's a building, some trees, and then I can tell maybe there's a bridge there and some sort of foreground. But I get all that information with very little data compared to the actual first image, because now instead of 3 color channels, I only need 1 channel, and all my values are actually just binary. They're either 0 or 255. So let's explore the syntax and options for thresholding with OpenCV. Let's open up a notebook and get started. Okay, we're going to begin by doing an import of CV2, and we're going to display some images. So we will say import matplotlib.pyplot as PLT, and then say matplotlib inline as well. The image we're going to use is an image of a rainbow that is located in the data folder. So we'll say image read, and wherever your data folder is located, go ahead and read in the rainbow JPEG file from there. Let's go ahead and see the image. So we'll say PLT, imshow, and then we'll say image. So there it is, there's the rainbow image. And what we're going to be doing is experimenting with a couple of different thresholding options. The first one I want to show you is how to actually read in an image that is in color and read it in grayscale. And the way you can do that is just as a second parameter, just pass in 0 when you read it. So say CV2 imread your image, and then second parameter is 0. And when you run it that way, you'll read it in as a grayscale image. Notice that the colors changed. That's because, as we've discussed before, Viridis is the original color scale for this. So we'll clarify with CMap equal to gray, and there we actually see a grayscale version of that rainbow. Now let's check out the different threshold types. The way thresholding works is you say CV2 dot threshold, and then you're going to pass in your image, and then there's going to be 2 main parameters. One is the actual threshold, and the other one is the max value expected. So what this does is this function basically is going to apply thresholding, and it's going to say any values below a specific threshold get turned to 0, any values above that get turned to the max. Now typically what you do for thresholding in a lot of situations is you just choose the halfway point to be your threshold. So in that case, our halfway point should be 255 divided by 2. So if we do that, we'll say 255 divided by 2, that's equal to 127.5, so you can choose either side of that. So we'll choose 127 because we want it to be an integer, and then the max value here is 255, and in case you ever have any doubts for your particular image, all you need to do is say image max, and then it'll report back. So in our case, the actual max value is 214, but we know the actual max possible value is 255. The reason you may want to actually check the max is in case your image goes from 0 to 1, but if you're reading it with CV2, then it should read it in to all go from 0 to 25, from 0 to 255 as the max. Okay, so we have our image, we have our threshold, and we have our max value possible, and then we'll go ahead and pass in the type of threshold. And in this case, we're going to say CV2 thresh, and if you click tab here, you'll see the various thresholds available. We're going to start off with the simplest one, which is binary. Again, any value inside of this image, which is below 127, is going to be shifted down to 0, and any value above 127 is going to be shifted up to this max of 255. So then what we're going to say is ret, comma, thresh1 is equal to CV2.threshold. So we do a little bit of tuple unpacking here in the way it gets returned. And if you check out this ret object, it basically just informs you what the actual cutoff value was in case you ever want to revisit that. And the thresh1 is actually an image. So we'll say plt imshow thresh1, and then say cmap is gray. And now you'll notice that we have a binary image. So all the values are either 0 or 255. Now you can actually do an inverse of this by saying binary underscore inv as a threshold binary inverse. So this does the exact same thing, except it inverts all the results. So if you run this again, you'll get back the actual inverse of binary. Those are the two most common we're going to be using, is threshold binary and threshold binary inverse, depending on the actual situation. Okay, let's explore a couple of more threshold options. Another threshold option besides thresh binary and thresh binary inverse is thresh, hold, and then trunc. And this is essentially a threshold truncation. So the way this works is if you actually look up in the documentation the various thresholds, you can open up the documentation link and you can see the actual way the formulas work. So we already are familiar with thresh binary, where you're going to have some sort of source and it's going to go either to 0 or the max value provided, which is 255 usually. And then thresh binary inverse is the opposite. It's going to go to 0 if the source of that value is greater than threshold, and then it'll go to max value otherwise. For thresh with truncation, what it's going to do is if it's actually over the threshold, then it's going to go to whatever you set it as. So if you set the threshold to 127, if the source happens to be greater than that threshold, it's going to bring back that value down to the threshold. Otherwise, it's going to keep the original value. So let's see what that looks like here. So we're going to say thresh truncated, run that again, and now we get to see the results here. So notice that some of them got to keep their original value, and then other ones got put down back to the threshold here. So again, that's threshold truncation, where all it does is if the source material is above the threshold, it gets pulled back down to the threshold. If the source material is otherwise less than the threshold, we keep that source. And as you may imagine, there's essentially an inverse of this, which is thresh to 0, where you're going to keep the source material if it's greater than the threshold, and then if you're not greater than the threshold, you're going to pull it back down to 0. So there's also an inverse of that as well. So we say threshold, and we can say, whoops, make sure that's 20. And if you run those, you basically get the normalized gray values here, and then anything that didn't meet that gets put back down to 0. So the formula again for thresh to 0, if we were above the threshold, we're going to keep our value. Otherwise, if we're below that threshold, we go down to 0. So you can see these right here went back down to 0. And as you may have imagined, there's an inverse for that one. So we can call that as well, and you basically get the opposite. These guys then go back down to 0, and these guys get to keep their original source values. Okay, so that's on a very simple image. Let's actually see a bit of a real-world application. We're going to go ahead and do a couple of things here. I'm going to read in a new image file. I will say cv2 imread, and then inside of my data folder, I'm going to say crossword.jpg, and then I'll say comma 0 in order to read it in as a grayscale. And if you just say plt imshow on this image, it actually appears very small, and we also want to clarify the CMAP here should be gray. So this is a crossword image. It's actually pretty blurry because it's a large image, but it's showing pretty small on the screen. What I'm going to do is set up a function in order to display this image. We'll say showPic. It's going to take in the image, and we'll say figure is equal to plt figure fig size, and in this case I'm going to make it quite larger. Let's say 15 by 15, and then we'll say x is equal to fig add subplot, and hopefully you remember that we actually coded this out ourselves manually in the very first section of the course. And then we'll say x imshow image cmap gray. So we've actually seen these 3 lines of code before when we were talking about showing images inside of a notebook, where now we're just functionalizing it into a convenient showPic function. And we're actually going to be using this function quite a bit throughout the course. But if we define this function, we can then show that image. And whoops, let's make sure we imported everything. Fig size is not defined, so that should be fig size equals 15 by 15. Now let's run those again. And there we go. Now we have this image here. So you can see here we have a crossword puzzle. And right now it's in black and white, but also we can notice here that there's a lot of information in gray that we don't really care about or need. For example, if we wanted to scan this and maybe do some sort of analysis on it, you'll notice here that over in the white space, the newspaper is appearing kind of gray. It would make a lot more sense if we would just say anywhere there's ink, it should be black, and anywhere there's not ink, it should be white. So we can just use a simple binary threshold and play around with this. So let's see what happens when we use a simple binary threshold. We'll realize that it's actually not super great at doing its job, and then we'll learn about an adaptive threshold, which is a little better. So we'll say RET and threshold 1, or whatever you want to call those two variables. We'll say threshold, pass in the image, and then pass in some value for the threshold and pass in the max possible value, which is 255. And then let's go ahead and say thresh, and in this case, let's use thresh binary. And then we will show the pic of the new thresholded image. So if you run that, you can now see that we've attempted to threshold the image. However, we're losing a little bit of quality here because some of the gray spaces, they got thresholded to white when we actually wanted to keep them as black. There's a couple different ways to deal with this problem. One is to try experimenting with the other thresholding types, and the other is to try experimenting with a different level of threshold. So maybe you decide to go for a higher threshold and run this and actually grab more of the ink. So you can see here, as I go with a higher threshold, I get to grab more of those kind of darker grays and treat those as ink. But again, that comes at the cost of some of the near spaces that are pretty dark gray. So maybe you want to lower this to some sort of in between 127 and 200. So you can start experimenting with this and see more and more what's an appropriate threshold. Another method to do is the adaptive threshold. And the adaptive threshold, what it does is it tries to automatically adapt its threshold based off the pixel and where the gray is around the pixel. So you can check out the notebook that we provide for a full explanation as far as the threshold parameters, because it is a bit confusing as far as what the parameters are. So we're going to go ahead and do adaptive thresholding on this image, and then we'll explain a little bit about what all the parameters mean. I will say threshold 2. Notice I'm not doing tuple unpacking for this one. And we'll say CV2, and then we're actually going to call a different function called adaptive threshold. And this is going to take in a couple of parameters. We first take in the image, and then we're going to say the max value. So the max possible value is 255. And then we're going to choose an adaptive method. So there's various adaptive methods available for us in OpenCV. So if you begin typing adaptive, you'll notice that there's Gaussian and mean. So these are just essentially averaging that methods that we can use for the adaptive threshold. And then we're going to also say the threshold type. So we can say CV2 and then say thresh binary. Essentially, after you do the actual adaptive threshold, then what kind of threshold result do you actually want? So do you want everything to be black and white, or do you still want grays available? After it's done, it's adaptive thresholding. And then you have two more parameters at the end, which is the block size and the C constant. The block size is the size of a pixel neighborhood that is used to calculate a threshold for a particular pixel. So what adaptive thresholding does is it's essentially going to look at a little neighborhood around a pixel to see whether or not the pixels next to it should be included. And it's up to you what kind of sizes you want. Usually people like to play with things like 3, 5, and 7. Keep in mind, it does need to be an odd number, just the way the math works. So we can choose something like 11. A little bit of experimentation is usually necessary here. And then you have a constant value at the end, and this constant is subtracted from the mean or weighted mean. And normally it is positive, but it could be 0 or negative as well. And again, check out the link in our notebook that gives a little further explanation as far as good guessing values to start off with. Usually this first one, you'll start with like 3, 5, and 7, and 11, just odd numbers and keep going up. This one you're going to kind of play around with, but again, it's all kind of guessing and checking here. It's a little bit hard to have a good intuition for these sort of values, but let's see the result of this and see how it performs. So this is now adaptive thresholding. So it's looking at neighborhoods around these darker values of pixels. And you can see here, it's kind of interesting because it recognized the dark spaces filled in the crossword. However, because due to the adaptive thresholding, since looking at neighborhoods, eventually it decided not to fill them in. So it still recognizes them, but it doesn't fill them in like it did previously when we went straight up with a binary threshold. And we can begin again experimenting with values more and more here with adaptive thresholding. And what we can even do is start mixing in ideas of things we already learned and actually blending images. So what we could do is blend this threshold 1 result that actually fills in these values with this threshold 2, which didn't fill in the values but maybe has clearer text. So the way we do that is just as we described in the previous lecture. We can say blended is equal to CV2 add weighted, and then we can just define what we want. So we can say source 1 is equal to that first thresholding, maybe give that one 60%, and then source 2, make that one the 40% of the image, so we'll say th2, where beta is then equal to 0.4, and we can set an gamma of 0. So that's our blended image, and we can end up showing a picture of that one. And if you run that, you end up getting kind of a little bit of a nicer result here. And you can experiment and match with kind of what the best results are. But this is also a common approach, trying to use something that is a blend of different thresholds. Often in kind of more serious applications, people will just use an adaptive threshold and keep updating these parameters until they get something that they're satisfied with. So I encourage you to really play around with these parameters. You can also play around with the Gaussian and see how that performs. So you can run that one and see how that performs compared to the median, and then also play around with these threshold binaries. You can even do an inverse if you really wanted to and get the opposite, and then play around with these sizes as well. Okay, so the main ideas here is that we can always threshold images to basically go from something that's in grayscale to only 2 binary colors, either white or black. And there's lots of different methods to do that, and we can even keep original values depending on the different types of thresholds we use. And I encourage you to check the documentation again and make sure you understand how to read this. So for example, threshold binary, over here on the left, it's going to tell you what the final result is. Over here on the right, it's going to tell you the condition that decides this final result. So if the source of x and y is greater than the threshold, then that value becomes the max value possible that you provided. Otherwise, it becomes a 0. So that's how you read this sort of mathematical notation. Okay, if you have any questions, feel free to post to the Q&A forums. We'll be using thresholding throughout the course. We'll see you there.